This segment will contain capsules of information in a straight sequence from departments across the institute which offer programs for undergraduate students. Here, what you will find is short videos made by the departments, and from each department, a representative faculty member telling you about the kind of courses that you can expect to find, the kind of learning experiences that you can expect, and also what sorts of recognition the department has garnered for itself, the way its alumni have prospered along the years, and so on. This section will last about an hour because there will be some dozen departments or so that will now present you with their offerings during your time over here.
So we at the Department of Aerospace Engineering are interested in things that fly or at least remain in the air for a long period of time. Anything that you can imagine, basically airplanes, helicopters, spacecraft, satellite, balloons. Our faculty and students try and understand the mechanism behind these flying objects, how to design and manufacture them. The discipline is divided into various sub-disciplines like aerodynamics, which deals with the forces which are generated because of air passing over a vehicle, propulsion, which gives thrust to the vehicle to travel up, dynamics and control, which is basically controlling the vehicle in air or in ground.
Aerodynamics deals with the motion of objects through air and the forces and the moments that the air exerts on the body as it moves through air. For a typical commercial transport aircraft carrying 400 plus people and weighing about 400 tons, the primary aerodynamic forces that one would be interested in are the lift force, which acts upwards and counteracts the weight of the aircraft, and the drag force, which acts like a penalty to moving an object through air. The primary objective of a researcher in aerodynamics would be to design objects which produce the required lift force, at the same time maintaining minimum drag levels.
The propulsion problem is to make an engine that works efficiently over a wide range of conditions. We focus on a few aspects of this complex problem. An airplane engine generates thrust by adding energy to the air flowing through the engine, and this energy comes from the combustion of a fuel. Can we generate thrust with less pollution? The combustion groups are working on improvement in the existing fuel injection strategies and novel concepts like flameless combustion to enhance the engine performance. We are also interested in understanding the combustion instabilities that can cause engine failures. Irrespective of the outside atmosphere or air, the air inside the combustor needs to be maintained at such a condition where combustion is possible, and there is only limited range where a turbomachine can meet these requirements. The turbomachinery group in our department is interested in understanding the intricate flow features of the turbomachine flows to make them more efficient and to work with larger margin.
Aerospace structures are driven by the twin objectives of high strength, stiffness, and lightweight. Aerospace Structures Group is responsible for physically realizing the shape or the aerodynamic shape of the aircraft under the given set of minimum weight constraints. They are also responsible for estimating the structural deflections as well as the structural strength under the given static and dynamic loading conditions. As part of the structures curriculum, students are exposed to various numerical and analytical techniques, as well as in the usage of advanced aerospace materials like composites and smart materials. The branch of aeroelasticity, which involves a study of aerodynamics, controls and structures, is also covered in the structures group.
Just like any other vehicle, aerospace vehicles such as aircraft, missiles, launch vehicles and spacecraft need to be controlled. Dynamics and Control Group works to develop methodologies and tools that help in ensuring a desirable dynamical response from such aerospace and other non-aerospace systems. This is achieved through development of algorithms for navigation and guidance, simulation platforms, and control strategies. The group also has a number of experimental facilities that help in verifying and validating the ideas.
So flight and flying has fascinated human beings from since time immemorial, ever since they looked up at the sky and saw birds flying and wanted to imitate the same. And it has been in the last 200 years that we have come to a point where powered and unpowered flight is possible. And this subject continues to make rapid advances, and this is what we are involved in as a department. Welcome to this short introduction to the Department of Aerospace Engineering, IIT Bombay. As the name suggests, it's a fairly exciting field, and I will tell you about how we go about imparting a kind of a degree in this particular subject. So as the name suggests, we deal with the science and engineering of flight. Anything which flies, it can be an aircraft, it can be a drone, it can be unmanned air vehicle, helicopter, rocket, missile, balloon, lighter than air, heavier than air, satellites, etc., etc. All of them come under the ambit of aerospace engineering, and we tell you about the underlying physics, mathematics, and design of these vehicles. These vehicles can kind of differ in scale from something like large commercial airliner which weighs around 500 tons to something like a UAV or a drone which can be few grams. But the underlying science and engineering is possibly pretty much the same. How it differs is in the requirement and how we design it. So all this is going to be taught to you. Typically, we separate out informally courses in certain baskets like aerodynamics, which deals with the flow of air around a vehicle, how the forces and moments are created, the propulsion, which is the engine part of it, the structures, the ability of the structure to withstand certain stress, certain loads, dynamics and control, the actual control of the particular aircraft. So these are kind of courses in baskets, but ultimately all of them have to come together to kind of create flight. And that's what the magic of flight is all about, and how it has kind of evolved. So how we go about it in a formal sense is, we start when you enter in your first year, you will be doing basic courses in science, maths, data analysis, introduction to humanities, etc., etc., to give you a good grounding in the analysis part. Then we'll slowly move into what can be called applied sciences like fluid mechanics, solid mechanics, control theory, and progressively into very aerospace specific applied science courses like aerodynamics, propulsion, flight mechanics, space flight mechanics, etc., etc. And finally, all of them come together in capstone courses like aircraft design, it could be air transportation, etc., etc. So there are a basic set of core courses which everybody will do, but there are a lot of specialized electives like on it could be on rockets, high-speed computing, etc., etc., which you can liberally choose from. You can do electives from other departments. You can do electives in a lot of disciplines. There's a lot of freedom here. There are a lot of types of courses. For example, it need not be just theory courses. Obviously, there are laboratory courses to support this, but there are hands-on kind of courses like supervised learning projects, BTech projects, aircraft design projects, where you, on your own or with a group of your friends, you will be designing something. It could be something which flies to a small extent. Okay, so what we are trying to tell you is, there's a lot of flexibility about the courses, but ultimately it is to the magic of flight which it is tuned to. Right now, if you look at the future, it is a very exciting time to be in aerospace engineering, because there's a lot happening. If you look at the government sector, DRDO, Aeronautical Development Agency, the Space Research Organization, there are a lot of live projects which employ our graduates. If you look at private industry, a lot of India development centers of big multinationals like Boeing, Airbus, Collins Aerospace, etc., where you could get employed. You have now homegrown majors in the private sector like Tata Advanced Systems Limited, where you can find employment. So this is where our graduates will find employment. You could go to higher studies. You could also branch out, because this is something which gives you a kind of a really fundamental grounding in doing things logically. So you're valuable to a lot of allied industries in addition to this. And it is, if you look at some of our alumnus, they have proved this. If you look at some of our famous alumnus is somebody like Dr. Kota Harinarayana, who was the first program director of the light combat aircraft, or the Tejas, possibly the India's most complicated engineering exercise ever. If you look at Dr. Sivan, who was the chairman of ISRO, both are our graduates. If you look at some of our graduates who have gone into allied or, been around, not in aerospace, but have changed disciplines, somebody like Salil Parekh, who is currently the CEO of the software giant Infosys, all of them are from our departments. So in short, it is a very exciting field. We look forward to kind of welcoming you to our department. Thank you very much.
You get up in the morning and then you brush your teeth. So the toothpaste, the polymers in the brush, all are related to chemical engineering profession. So right from there to pharmaceuticals and drugs that you use, to the plastics that you use, you take fuel to reach your destination. All this is because of chemical engineering. So the chemical engineering covers a large day-to-day aspect of our lives, which will be useful for the society and the environment at large.
Over the period of time, chemical engineering has acquired a very strong interdisciplinary character. We are at a crossroads of all the three sciences: physics, chemistry, and biology. One of the strong points of chemical engineering is systems engineering or systems viewpoint. Now, equipped with systems viewpoint, chemical engineers have forayed into a wide variety of application areas, such as chemical vapor deposition in semiconductor industry, polymers, soft materials. The list is very, very long.
So when I say process intensification, it is to do with the enhancement of the performance of the entire process. Now when I say process, again, it is reactor and then so many units which are connected together. They together work and finally produce a product of interest. Now what we are trying to do, and in fact we have worked on several processes, is to combine reaction and separation in a single unit. While doing this, reaction enhances or reaction helps separation and separation helps reaction. So you get some kind of synergism and the overall enhancement in the performance.
Chemical engineers are able to model systems from nanoscale to macro scale, and we are able to connect between different scales, models between different scales.
So bacteria are tiny chemical factories that can produce a lot of products of human use. However, mostly these bacteria produce these products at very tiny quantities, enough for their own consumption. In the modern world, we use genomic innovations such as the sequence of the genes that are present in these bacteria to be able to produce super producers, which can make any product that you want and enough of it. In our lab, we work on one of such products, such as the monoclonal antibodies, which are what you use for your treatment of cancer and arthritis. Our objective is to be able to create these basic animal cells, which can produce large quantities of these antibodies so as to still retain their efficacy, but also bring the costs of these products down considerably.
Sustainability is all about preserving nature's ability to nurture us. The 5 elements of nature: wind, water, energy, fire, soil and ether, earth and ether, essentially provide us bountiful amounts of natural resources to conduct our daily practices and our industrial practices. In sustainability engineering or green engineering, the focus is on using technology to fight its own evils and promote nature's ability to nurture us.
Why does a toothpaste flow only on application of a certain force? Shampoos clean hair and are very soft to touch. Can we minimize drug dosage by creating smart materials? These are examples of soft materials which typically flow much slower than simple fluids such as water and are highly deformable as compared to metallic solids, for example. Now, one of the research areas in our department is to synthesize, characterize, and process these soft materials. These materials have time-dependent properties. For example, the same material can behave like a liquid or a solid depending upon how long you look at them. On a microscopic scale, one can punch temporary and permanent holes in a cell membrane in a biological cell to transfer drugs and genes into the cell or to conduct electrochemotherapy.
In my research, we employ computer modeling and simulation to understand the role of materials that are commonly used in a variety of energy application devices such as fuel cells, batteries, and catalysts. Now, what happens is in many cases, you would find that these devices are fairly complicated because there would be a number of components and different materials are being used, some of which might be undergoing structural transformations as well as chemical reactions over a period of time. So as a chemical engineer, we would like to know what is happening inside these devices so that we can come up with better designs for these energy devices.
Chemical engineering touches the lives and day-to-day lives of people in the society, and therefore this is an exciting profession to be in so that you can contribute to the upliftment of the society.
The Department of Chemical Engineering at IIT Bombay is not only among the largest in the country, but one of the top-ranked departments. It boasts of excellent faculty. Several of its members have won national and international accolades. So what is chemical engineering? Apart from common science, mathematics, computer programming, and general engineering courses, there are 4 foundational subjects that distinguish a chemical engineer from other engineers. The first is thermodynamics, which deals with equilibrium states of pure solids, liquids, and gases, as well as their mixtures. It also predicts the feasibility of conversion from one state of matter to another and the energetics of the processes. The second course is chemical kinetics and reaction engineering, which comprises of measurement, enhancement, and control of rates and extent of chemical reactions. It also includes the design of appropriate reactors to achieve desired conversion of reactants to products in economically relevant timescales. The third subject is transport phenomena, which is a unified approach to measure and predict rates of heat, mass, and momentum in fluids. The principles are used to design equipment for the efficient mixing or separation of chemical species, as well as the addition and removal of heat from process streams. Finally, the fourth subject is process design, optimization, and control, which relates to design, optimal operation, and control of equipment in a chemical plant. The chemical engineering program is a lot more about engineering and a little less about chemistry than some students tend to think. A large part of the program comprises of using mathematical modeling and computer simulations for prediction and optimization of the various chemical process outcomes. Apart from foundational chemical engineering courses, the new undergraduate curriculum allows students to choose a wide range of electives. By crediting additional advanced courses, students can earn an honors degree in chemical engineering. Students can also register for supervised learning programs and BTech projects to be mentored by faculty in carrying out cutting-edge research. Students may also earn a minor degree from other departments, centers, and schools, such as bioengineering, computer science, economics, industrial design, management, and operations research, to name a few. Several multinational companies, Indian multi-industry business houses, as well as startups from a wide range of sectors recruit chemical engineers from IIT Bombay. These companies include oil and gas, petrochemicals, biotech, green energy, educational technology,
information technology, software, data analytics, as well as engineering and financial consultancies. These are only a few things that make chemical engineering at IIT Bombay a preferred choice for students. Thank you.
Chemistry is an ancient branch of science with many modern challenges. It involves making new molecules and materials. Of course, it's not enough to just make them. One needs to characterize them and think of applications. Here in IIT Bombay, we constantly try to push the frontiers of chemistry and come up with new excitement in the field.
Our department was created in 1964 and was fortunate to attract a group of very senior scientists from National Chemical Laboratory, Pune. Since late 70s and early 80s, it began attracting generous funding from Government of India and industry and has successfully developed very good infrastructure for modern research.
We are fortunate to attract good faculty members over the years, and many are leaders in their area of research. Some are associate editors and some are editorial advisory board members of many international journals.
Traditionally, Department of Chemistry at IIT Bombay has very strong presence in the domain of chemical synthesis. More than half of the department faculty and student is engaged in developing new strategies for making new chemical entities which are relevant to the problems in biology and materials. We have strong expertise in the domain of total synthesis of complex molecules, carbohydrates, peptides, and nucleic acids, which are very relevant to solve infectious disease problems.
Chemical manufacturing via traditional batch process suffer from the frequent accidents and environment hazards. In our lab, we develop continuous flow process and help industries to convert their traditional batch processes into continuous flow processes. We have trained many industries which include Reliance, Syngenta, Dr. Reddy Labs, Sun Pharma, Anthem Biosciences, and hope in coming years we can help many more industries to convert their batch processes into flow processes.
Chemical catalysis is an important thrust area of the chemistry department at IIT Bombay. The key focus areas are in CH activation, homogeneous and heterogeneous catalysis, bioinorganic chemistry, electron transfer, magnetism, and computational chemistry. Several research groups who are leading experts in the area are driving research at the department and are supported by sophisticated instrument facilities available at the department.
The Department of Chemistry has a very strong and vibrant chemical biology program, and we are attacking various problems like in the field of membrane transport and architecture. We are also having a lot of problems in vaccine development where specialized synthetic technologies to make glycoconjugates have been undertaken. In the field of nucleic acid chemistry, we make DNA, RNA analogs for G-quadruplex inhibitors, etc. and a strong X-ray crystallography program to complement it, where we study problems pertaining to antibiotic resistance and biosensing.
Research in the area of materials chemistry in the department spans over both theoretical and experimental aspects of nanomaterials, magnetic materials, biomaterials, and soft matter. My own research has primarily dealt with developing molecules that are permanent magnets at high temperatures. In addition to this, we synthesize porous solids for energy applications and inorganic solids that can be delaminated to single layers such as graphene.
Our group works on intermolecular interactions, which is basically to understand how molecules interact among themselves. We use a variety of experimental techniques using lasers and mass spectrometers to understand this interaction and couple it with theoretical modeling. A simple question that we are trying to address is that how Teflon makes cookware non-stick, and can we use similar strategy to understand to make molecules and biomolecules unstick for therapeutical advances.
We use quantum mechanics to explore structure and dynamics of molecules. We also use classical molecular dynamics simulations for very large molecules such as proteins and nucleic acids. We are also interested in theoretical systems biology and we develop and apply statistical and mechanical models to explore a large area of soft materials.
We work on advanced nanomaterials. To do a high quality research in this area, one needs to have sophisticated facilities like electron microscopes, lithography facilities, etc. IIT Bombay is one of the few institutes in India have these facilities. Chemistry department at IIT Bombay has a very strong research culture. Apart from facilities, it also provides very good startup grant. What is more heartening is to see our alumni in many good institutes like IASC, IITs, ICERs as faculty members. Looking forward, we should continue to attract good faculty members. As we have a very strong visiting faculty program, we should try to attract many foreign faculty members in the next few years.
The foremost reason of choosing the Department of Chemistry at IIT Bombay is the highly versatile and conducive research environment present here. The Department of Chemistry in general and the institute as a whole provides excellent infrastructural facilities coupled with the perfect platform to carry out high-end interdisciplinary research, which is both rewarding as well as satisfying. And finally, IIT Bombay attracts the best crop of students from all over the country, which gives us a perfect chance to not only shape their ideas, but also to contribute towards nation building.
Hello, let me congratulate you for your success in JEE Advanced. I'm here to talk to you about the Department of Chemistry, which is one of the best departments, not only in our institute, but also in the country. Our eminent faculty, world-class research facilities, and excellent students have ensured that we are a department of reckoning across the world. If you join BS Chemistry in IIT Bombay, not only do you get some of the best teachers, you get an excellent peer group, the size of which is significantly smaller than most of the other departments in our institute. And that gives you an opportunity to interact intricately with your friends and gain from each other's knowledge. And it also allows you a closer interaction with the faculty. Our curriculum is very highly flexible. There are many courses that you can study later on. You can choose whether you want to study more courses in biological applications of chemistry or materials or something else. You also have the option of staying an extra year and go not only with a BS in chemistry, but also a master's degree, which is not necessarily in chemistry. You can take advantage of our interdisciplinary dual degree program to go with BS as well as MTech in the discipline of your choice. So this provides you a world of opportunities, not only in core chemistry, but also in all other sectors. Before getting there, let me just clarify a doubt that might be there in some of your minds. As we know that life in IIT Bombay is not about academics only. It's also about all these student activities that we have in the institute. And sometimes new students or aspirants often have this doubt that as a BS student, will I be a second-class citizen compared to BTech students? The answer is an emphatic no. Our students have participated actively in all possible institute councils, hostel councils, and other activities. So please do not worry about that aspect. If you want to do anything, even beyond the curriculum, it is up to you to do it. Nobody will stop you. After you get your degree, you can get into higher education like a PhD. And there our students have gone to the best possible places as is depicted in the slides. Or you can opt for non-core jobs. And there you see our students have gone to companies ranging from BASF, one of the largest chemical companies, all the way to Goldman Sachs and American Express. Our alumni have done phenomenally well. We have a managing director in Goldman Sachs. We have entrepreneurs. We have administrators. As you see, Mr. Vijay Nehra, Secretary, Department of Science and Technology, Government of Gujarat. We have people who have gone into core research, scientists. We are very proud of our alumni, not only from distant past, but also from very recent. Many of them are in touch with us and they give back to the institute as a mark of their gratitude. And our students take advantage of the network that they have with the alumni. We look forward to having you among us, and in this slightly dated picture of the department, we look forward to filling these white oval shapes with your smiling photographs. Thank you very much, and we look forward to having you among us.
Civil engineering is the mother of all engineering. And in a way, it is said that civil engineers make civilization.
Civil engineers actually plan, design, maintain, and also to some extent operate all the infrastructure systems. So they actually do this job of building infrastructure for the society.
Our department started in the beginning itself in the 1958. There are three major areas of civil engineering, that is structural engineering, hydraulic engineering, and soil mechanics. Of course, we also had faculty members in surveying, remote sensing, construction engineering. By 1963, the department had about 30 faculty members, and structural engineering formed the major discipline in the department.
So the structural engineering specialization in civil engineering department of IIT Bombay is the strongest group in the civil engineering department. The most obvious applications of structural engineering are in things like design of buildings, bridges, other major structures, aerospace structures, satellites, aircrafts, and so on. And some of our colleagues even deal with the biological structures such as bone implants, tooth implants, and so on.
Some complex material like concrete, right, where you mix up some powder, cement powder, with some kind of stones and some sand to get this concrete, and this becomes an amazing material, right? I mean, let's say, for example, a high-rise building, to retain that liquid form for a long time so that it can be pumped in the 100th floor or 200th floor, and then becomes a solid there, and then retains its shape for 100 years.
The centrifuge modeling is a physical modeling technique in which a small-scale model is subjected to high gravities by rotating about a vertical axis in a horizontal plane. And this is very much required in geotechnical engineering. And to this effect, the equipment commissioned at IIT Bombay in 2001, which is unique as far as IIT Bombay in India is concerned, and which is one of the largest equipment in this part of the world, and it can carry 2.5 tons at 100 gravities.
Some of the major projects in which I have been associated is the Bandravali Ceiling project, which is an iconic structure, seaport development, 4th container terminal for the JNPT, and City and Industrial Development Corporation of Mumbai, CITCO, where we try to create new cities or the smart cities.
Transportation Systems Group focuses on developing good transportation system. We focus on three major areas of transportation, namely transportation planning, design and construction of traffic facilities, and operation and control of various transportation systems. Understanding the traffic is another area. All this is intended for a very good, efficient, and a safe transportation system.
The Faculty of Ocean Engineering specialization work on various issues of coastal and ocean environment, and we work on various issues like wave focusing, wave modeling, tidal hydrodynamics. We work on the design and analysis of coastal structures like port and harbors. We work on the design and analysis of offshore structures. We have a physical wave flume, which is of 50-meter length, 1 meter wide and 1 meter deep. And in that, students do their experiments with physical models.
When you're talking about water availability, 80% of the available water comes from monsoon. That's the rainfall which occurs during June to September, these 4 months in India. And when you're talking about demand, the major sector of water demand is the agricultural sector. When you're intensifying the agricultural activities, you need more water. And at the same time, because of climate change and global warming, there is an weakening trend of monsoon rainfall.
So some of the important aspects we deal in water resource engineering include fluid mechanics, where all the aspects of fluid flow, dynamics, and all those things are considered. Then we deal with the hydraulic engineering, where, say, for example, construction of canals, dams, and then reservoirs and hydropower. And then also like water supply and some aspects of environment engineering, where, say, how to collect the water from a river or a reservoir, and then say do the appropriate treatments and then supply to the say city or the village is considered. After the water is supplied, there will be wastewater will be produced, and then how to treat this wastewater and then deal with it. And then also urban related issues like urban flooding, urban water management, all these issues will be there.
Nowadays, a discipline has started, cannot stand on its own. If I need to plan a city to give it a good flood warning system with a better lead time, I need information from all branches of civil engineering, and this is where the importance lies.
Our Department of Civil Engineering holds various technical activities through Civil Engineering Association, and the Civil Engineering Association holds seminars for various national and international experts. We also conduct technical events like ACAR.
ACAR is held annually and is one of the Asia's largest civil engineering festival. We have a lot of competitions, events, panelists coming over and giving lectures, and many other exciting workshops going on in ACAR.
What we also provide is every year we take on a hot topic and focus on it. ACAR also has a social responsibility, so every year we take a social cause and look to impact some lives in the best possible way which we can.
So civil engineers actually use very high-end equipment for testing the materials that actually go into all these structures, and also to test these prototypes of these structures. So in fact, our civil engineering department of IIT Bombay has 20 high-end teaching and research laboratories.
We actually get to see plenty of things hands-on in the high-class laboratories that we have over here, and yeah, it's been terrific. I have been part of ACAR, so I know what it is to promote the core interests of the department. So yeah, it's been a great experience.
Civil engineering is an exciting profession because at the end of the day, you actually see what you have created, whether it is a tall building, whether it is a bridge, or whether it is a metro station or a dam. So you can actually see the end result. And for years together, sometimes even hundreds of years together, people talk about that structure which has been built by a particular civil engineer.
This is Nagendra Velaga, and I am from Civil Engineering Department working here as a professor. Civil engineering is one of the oldest engineering disciplines. It deals with the design, construction, maintenance of various civil infrastructure such as roads, buildings, irrigation structures, canals, dams construction, and so on. And in the last few decades, the civil engineering is becoming very interdisciplinary. And as part of the civil engineering, we do use the components such as the machine learning, artificial intelligence, data mining, big data analytics, and also certain latest tools. We use it for design, construction, and maintenance of civil infrastructure. For instance, in case of the traffic engineering, we do get the traffic related data and we do the big data analytics, and further we actually develop the signals. And in case of the construction management, a lot of advanced tools and techniques are used. With this, I would like to welcome you to IIT Bombay, and my colleague Professor Albert will be explaining you about the job opportunities.
Hello everyone, my name is Albert. I am working as a faculty at the Department of Civil Engineering, IIT Bombay. First of all, congratulations for getting a JEE score. So I'll talk about the career prospects and opportunities after finishing your undergraduate degree here. The first one is industry-based opportunities. So when you talk about industry, you can do consultancy-based job opportunities. That's what most of our students go. In terms of design consultancy, where you design the building, you talk about the structural safety, structural aspects of the buildings and so on. Another aspect of consultancy is project management consultancy, where you interact with different parties in a typical construction project and then you manage that project. So students who have a management interest pursue such career streams. And you can also work in pure construction contracting firms, where you will work in areas like planning of construction projects and implementation of various construction activities. When you look at the future studies standpoint, that's the second part. You can pursue master's degree or MTech degree in a field which is of interest to you. You can also do a PhD and you can still, after a PhD means much more specialization into some domain, and then you can come back to academia, you can teach, you can do research, or you can get back to the industry as well as an expert in some domain. So another opportunity is in terms of the government sector. So you can write engineering services and you can be in the leading friend from the government side in terms of civil engineering related projects and civil engineering related departments and so on. So there are a lot of career opportunities as being an undergraduate student here at IIT Bombay. So welcome you to IIT Bombay and see you here.
Computer science involves building suitable models of the real world so that they can be processed to find good quality answers in reasonable time. These days, computing is moving to clouds, making much larger volumes of data available, opening up newer applications.
Every time you travel in a train or an aeroplane or a rocket goes up in space, there are several software and hardware systems that ensure that everything goes right. How do we ensure that these systems never malfunction? We try to answer such questions by building mathematical models of systems, expressing properties in logic, and building algorithms to automatically verify these properties.
Theoretical computer science is a field that deals with fundamental questions such as what can and cannot be computed and how efficiently. Our department has a diverse set of researchers working in various aspects of theoretical computer science such as optimization, complexity theory, cryptography, and graph theory.
Internet technology-based communication is the centerpiece of the digital information age. In our department, researchers in this domain of networked computer systems work on various aspects of this area. We design protocols, the language of bits and bytes used in communication networks.
We tell a computer what to do by supplying it a program. Researchers at IIT Bombay are working on ways to make the programming process more convenient, on speeding up the execution of programs, and on making sure that they run with as little memory as possible.
The world is awash in data today. How to store and query data is the focus of our research. Our research has had significant impact.
Well, so the field of artificial intelligence considers how agents can sense, think, and act in the real world. The field has really blossomed in the last 10 to 15 years, thanks to the availability of large amount of data, faster computers, and so on. But that doesn't mean there aren't any challenges left. It is sometimes said that AI can play chess better than human beings, but it doesn't have the common sense reasoning of a 3-year-old child. Acknowledging that AI is very vital for the future technological growth of the country, we work on all aspects of the field in our department. List scientists along with the musical instruments they played. What's the typical battery life of a Lenovo ThinkPad? How many countries in the world have more rivers than Brazil? I am building systems that deeply understand the structural intent of such queries and then use knowledge graphs and unstructured text to answer such questions accurately.
At the CSE department in IIT Bombay, we study many aspects of computer graphics. Like we model how rays of light bounce around in the real world to create colors in images. We develop computational tools for rapid visual exploration of geometry and shape spaces to aid design.
But we have to go beyond generating images. We need to understand images. An example of image understanding is in your mobile phone, where your face is automatically recognized and you are authenticated. But we can do other applications, such as in the hospital, where a doctor is assisted in identifying cancerous cells in histopathology images, or even in the entertainment industry, such as the mudras of a Bharatanatyam dancer.
India's emerging economy requires automation in the fields of agriculture, healthcare, transportation, and so on. IIT Bombay's CS researchers are contributing to this effort. Examples are the T10KT project, which involves training teachers in other colleges. Second is the E-ENSLA project, which involves establishing robotic labs in several colleges across the nation. Third is a project which is empowering buildings with computational techniques to better manage the energy so that consumption can be reduced. Using computational techniques thus contributes to the emerging technological prowess of India.
Computer science at IIT Bombay is one of the top destinations in the country for not just undergraduate students who come here for the excellent instruction that we provide, but also for postgraduate students and researchers who are here because of the quality of the faculty and the depth of research that goes on across various fields and the facilities that we have here in the department.
Computer science and engineering is all about doing fast and accurate computations. Computation can mean a wide range of things, something as simple as adding or multiplying two numbers, or more complex things like designing a schedule for the local train network, computing a spacecraft's optimal trajectory, translating from one language to another, retrieving correct messages when your communication channel is error prone, predicting tomorrow's weather, and so on. Behind all these computational tasks, at a fundamental level lies logical reasoning and mathematics. If you like these subjects, then you will find computer science quite exciting. The UG CSE curriculum at IITB consists of a set of core courses which introduce you to the basics of computer science, a large number of elective courses which you can choose depending on your interests, and other courses in basic sciences, humanities, management, design, etc. You have a lot of flexibility in choosing courses. You can either go for the breadth, taking courses in many different areas, or go for the depth, taking basic to advanced courses in one area of your interest. Computer science courses can be broadly classified into three streams. The first is computer systems courses, where you will learn things like how computers are designed, what are the internal mechanisms that work between the computer interface you see and the basic electronic components a computer has, how email works, how the internet works, how large amounts of data is stored and accessed, how programming languages are designed, and how computers understand them. The second kind of courses are about the mathematics and the theory behind how computer works. They deal with questions like what kind of things can a computer compute and what they cannot compute, how to design fast algorithms and correct algorithms for various computational tasks. Are there any limits on how fast something can be computed? How do we guarantee that a program or a software application works correctly as desired, and how can we test that? How do we ensure that our communication is secure? How can we ensure that our data is kept securely? In particular, these courses train you to think and communicate in a mathematically rigorous way. The third and the most popular stream is that of artificial intelligence, machine learning, and data science. At a very high level, it's about making computers think like a human, make decisions like a human, understand languages and images like humans do these things even faster and more accurately than humans. Some of you may find it surprising that foundations of this stream are built heavily on mathematics, more specifically on probability, calculus, statistics, and matrices. Our courses cover these foundations, will also provide you training to use AI/ML tools for real-life applications. Coming to the future prospects, there are many exciting job opportunities across many different areas of computer science, where you will build large-scale systems in companies or work in cutting-edge AI/ML companies, or you can start a company based on your own idea. There are also fantastic opportunities in non-CS areas that use CS concepts, like writing algorithms that can do trading in financial markets. Another great option is, of course, to go for higher studies and pursue research in a specific area, eventually building a career in industry research labs or academia. Finally, while computer science is naturally one of the most preferred branches for many students, it is also important to see which subjects align best with your aptitude and interests. We hope that you will make an informed decision to make the best use of diverse opportunities IIT Bombay provides.
Hello, I'm Professor K. Narayanan, currently the head of the Department of Economics at IIT Bombay. The BS Economics program was started in 2017, and this will be the 6th batch that we admitted to this program. The advantage of being located in IIT Bombay is that the students have opportunities to learn core theoretical as well as applied subjects in economics, as well as to pursue a minor in the area of their choice, like computer science, electrical engineering, or the basic sciences, mathematics, or management. They are also exposed to courses in policy studies, so they will become multidiscipline candidate at the end of the 4-year program, who will be ready to join the corporate sector or the consulting sector or the government organizations. So some of our students in the past have joined big consulting companies like Barclays or PricewaterhouseCoopers or Bain Consulting. They also joined organizations like Goldman Sachs, Microsoft, and the like. And some of the students have gone into higher education in top universities in the world. So these courses that we teach in IIT Bombay will train you in both the basics of economics as well as in applied courses. And several of these applied courses, for example, are like behavioral economics, health economics, industrial economics, courses in finance, econometric methods, which are highly useful for data analytics, handling big data in the financial sector especially.
I am Professor Ramapal at Department of Economics, IIT Bombay. We started undergraduate economics program in 2017. This program offers unique advantages to the students. We emphasize on rigorous quantitative and analytical approach to understand different economic problems, and then this analytical framework is linked to the real life situations as well as recent developments in the field. Here, students get opportunity to work on real life problems as part of various research internship schemes. Under these research internship schemes, they assist faculty members in their research and get the real life exposure to the decision making related to businesses as well as policymakers.
First of all, we will be inducting students directly from joint entrance examination, and in first year they will be taking courses with other engineering students in math, science and other subjects. Even though we will be teaching the common economic courses, but these courses will be more analytical and quantitatively driven, and as such they are going to have a better exposure to the new way of economics thinking. Third, since being housed in IIT Bombay, these students are free to take other courses from various other departments beside their core subjects, and other subjects are the elective subject economics.
Welcome. I am Professor Surajit Bhattacharya of Department of Economics, IIT Bombay. Department of Economics, IIT Bombay had been offering the BS Economics 4 years undergraduate program at par with all other basic sciences and engineering degrees that IIT Bombay offers. Our students had always been very competitive, and they had been recognized in various competitions. Our program is primarily applied mathematics based. It's highly grounded to the theoretical concepts, and therefore in the subsequent years our courses are majorly applied, where we train our undergraduate students to use the tools of mathematics, econometrics, statistical methods into real-world applied problems. Some of our students have directly got into KU Leuven, Wharton, IIM Lucknow for their future higher degrees, and many others have got into the top-ranked private corporate houses. We wish that people who will be joining this program are willing to take the rigor and analytical methods that we would like to impart upon them. Thank you.
Today we interface with our world through electrical systems that enhances our 5 senses. In the age of WhatsApp, Skype, even satellites, we receive data from far away instantly.
The data is generated from the microphone and converted into digital format using data conversion schemes. Power balancing and supply problems are resolved to ensure uninterrupted power. This data can be sent everywhere, even into space and far stars, because digital data is easy to read. Logic, control, and data processing are powerful concepts for ensuring operation. But who is the controller, the logical processing? It is the chip. Arguments are converted into the language of circuits. Finally, each circuit element is critical, where electrons and photons are controlled to create, carry, and convey data. Human endeavor is served by understanding the past, solving the present issues, and imagining the future. Our community of faculty, staff, and students is committed to working on all these 3 aspects.
Devices and circuits form the hardware on which all ideas are implemented. The devices program at IIT Bombay is built around the IITB NanoFab, which is the most advanced academic nanoscale fabrication facility in India. The lab conducts research in device physics and engineering. We typically start with device design to account for nanoscale and quantum effects, materials growth and characterization, and then finally, nanoscale device fabrication and testing. The key focus for research and development are devices for logic and memory, neural networks, power switching and high-frequency devices, optoelectronics and MEMS, and spintronics and quantum computing. Photovoltaics is another key area. In fact, we host NCPRE, which is the National Center for Photovoltaics and Renewable Energy, the largest photovoltaics lab in India.
We live in an analog world. Our RF analog mixed signal circuits group at IIT Bombay specializes in reliable extraction and conditioning of really tiny signals with high fidelity in an extremely noisy environment, and then convert it to digital for further processing in a standard CMOS technology. We are developing RF system on a chip, SoC, for India's own GPS program called NAVIC. Our focus is on high-performance integrated circuits for optical communications, biomedical, agricultural, as well as ultra-low power sensor network applications. Our faculty is pushing the research envelope all the way from antennas to digital signal processing as well as the processors. We are on the forefront of developing technologies which will support the industry ecosystem as well as solve the India-specific issues.
Control is about analyzing and synthesizing controllers that achieve automatic control of a given system with respect to a given performance objective, like for example stability, minimum fuel consumption, etc. Increasingly, controllers are being designed using computational software packages that can simulate and design controllers based on various criteria. This has made computation central to the control problem. In Control and Computing Group, we deal with analysis and synthesis of controllers for various classes of systems with emphasis on both theory and applications. The group's research and experimental facilities include outdoor multi-UAV platforms, lighter-than-air platforms, high-performance computing facilities, autonomous driverless vehicle testing facilities, etc. The group members work in close collaboration with other engineering disciplines that include power systems, energy systems, avionics, haptics, etc. In summary, the Control and Computing Group is one of the leading research entities in control, both within this country and internationally.
The electricity sector is rapidly evolving to accommodate a high penetration of renewables, advanced communication and control technology, as well as new power electronic devices for high voltage applications as well as renewable integration. The PEPS group at Electrical Engineering is actively involved in the research and associated development. Our group has developed softwares which are being used by regulators as well as utilities. PMUs developed by us are deployed in fields. We have also developed real-time simulators for educational purposes as well as low-cost power electronic converters for rural applications. We believe that our contributions will go a long way into ensuring a smart, secure and sustainable grid for the future.
In the past few decades, we have witnessed a revolution in the field of telecommunications and networking,
and our department has been contributing to this revolution in terms of academia, research, as well as policy. We have several faculty members and laboratories focusing on areas such as signal processing, fiber optics, as well as wireless communications. Many of our projects are motivated by practical issues rising due to the lack of connectivity in the country. For instance, one of our projects focuses on providing voice and data connectivity to rural areas which have traditionally been deprived of these services. As a result of this project, several villages now have access to cheap data and voice connectivity.
Electrical systems are everywhere. Every day, new solutions enable humanity to progress towards a better future. These solutions are invented by smart engineers in a creative ecosystem. Our department equips students to be such agents of change. We invite you all to be a part of this adventure.
Hello students, my name is Rajesh Jhele. I am professor in electrical engineering at IIT Bombay. I would like to tell you all about our department of electrical engineering. Let me tell you first about myself. I did my Bachelor of Technology in Electrical Engineering from IIT Bombay long time ago. I worked in the industry for a couple of decades, and after that I have come back to IIT Bombay as a professor. Generally, the students have a question in their mind about electrical engineering, what electrical engineering is. And you tend to think that electrical engineering means big machines. But electrical engineering by definition means something a lot more than that. Any device, any component through which electricity flows, the study and design of those topics is all about electrical engineering. So it just doesn't talk about only big machines, but also nanoscale devices, all the way to quantum computers. Our department is the largest electrical engineering department in India. We have about 1,300 students on roll and about 70 faculty, and they're growing. The average age of our faculty is about 45. And that tells you that we are a very young and vibrant community as teachers for you. The department has R&D focus, and we have about sponsored research about 225 crores in last 5 years. We have various high-profile labs in the department, which contain many center of research and excellence in the department. We give a lot of emphasis on publications and patents, as well as we take pride in our teaching techniques. Let me tell you 6 different specializations in which our department is focused on. But that doesn't mean we are limited to only these specializations. The first one is a power electronics and power system. As the name suggests, this is one of the most important things in the coming years for India as such. All our devices, everything works using electrical power. And this particular specialization focuses on generation as well as design of these systems and machines. There is a R&D support that we provide for national electrical power infrastructure. We not only deal with electrical machines, but also lately it's been an important area in the design of electrical vehicles that all of you are aware of. We also focus on solar power because that's the next solution that we are looking at for our increasing demand in power. The second specialization is communications and signal processing. In this area, we deal with wireless communications, microwave RF antenna signal processing, fiber optics, photonics, communication networks, and computer vision. Media and image processing are also part of this specialization. We have various high-profile labs in our department, including antenna and microwave lab, Bharti Center for Communications. The third area of specialization is control and computing. This deals with mainly automatic control, computational method for system theory, cryptography, coding theory, and dynamical system. The fourth area of specialization is electronic systems. In this area, we are focused on building large systems using the components which are available. This involves embedded system design, signal processing, biomedical electronics, electronics instrumentation, as well as audio and speech processing. Many of us build systems. We have PCB labs in our department to do all these things. Fifth area of specialization is ICS, Integrated Circuits and Systems. This involves development of integrated circuits. Specifically, you must have heard about shortage of semiconductors during the COVID times. And this is one of the very important areas of research for India in upcoming years. And in this specialization, we do design and development of integrated circuits, specifically microprocessors, architectures, then design, test, and verify these large digital systems. We also focus on RF millimeter wave integrated circuits design for communications, navigation, imaging applications. We also have photonics IC design, wireless and wireline communication IC design, biomedical applications, and agricultural applications IC design. So if you like to work in this area, our department is one of the strongest departments. The sixth specialization is solid state devices. In this, we deal with actually building devices in the lab and all the various steps you have to take to build these devices. So our professors are experts in that area. We have our own lab called a nanofab in the department where you can experiment. So starting with nanoscale technology, we are building devices in the lab. We are doing quantum computing related research. Also neuromorphic computing is done in our department. We also have a very strong focus in artificial intelligence and machine learning in our department. There are various courses offered by our department which are specifically focused in this area for electrical engineering related applications. In summary, I would like to leave you with one message. That is, if you like to build things with your hands, program them, code them, then electrical engineering department at IIT Bombay would be the right choice for you. Thank you very much.
Energy is required for all activities of life. The challenge before us is to provide an increased level of energy services because there is a direct link between energy services and standard of living. We have to do this in a fashion that is more affordable and sustainable. The Department of Energy Science and Engineering is a unique blend of students and faculty who work on all aspects of the energy problem, from the nanoscale and novel materials to devices, smart grids and large-scale centralized energy systems.
Sunlight is our largest resource of renewable energy. Several of us are working on the science and technology of devices that convert sunlight to electricity, namely photovoltaic or PV devices. There are people who are working on the development of new and improved materials like perovskites and chalcogenides, as well as synthesis techniques to make them cheaper. In addition, we are also working on the direct conversion of sunlight to fuels, as in a photoelectrochemical water splitting cell.
Nearly all consumer electronics nowadays use lithium-ion battery due to its super energy and power performance. But we are interested to have our mobile phone to run for a week in a single charge. An electric car should be charged in 5 minutes and run for 500 kilometers. But looks like this one is unrealistic now, but can be possible if you change your electrode design, if you change your advanced material design, also manufacturing process. At IIT Bombay, our team is working on these perspectives.
So we have several groups that work on the mathematical modeling of chemical and physical processes, and these are first principles models. And we look at length scales all the way from angstroms to meters. So using one such model, we've been looking at analyzing how a particular material catalyzes the fuel oxidation reaction in a fuel cell anode. And using this understanding, we can now propose better materials and test them, at least on a computer.
Renewable energy is intermittent in nature, and this poses significant challenges to the grid stability and power quality. We work on designing systems that ensure that the power quality and the grid stability is not compromised in a high renewable environment. We also work on design, control and development of highly efficient, low-cost power conversion systems for solar, wind, electric vehicles and microgrids.
The Department of Energy Science and Engineering at IIT Bombay is a fun place to be. As a part of my first course in energy, I used a solar cooker along with my friends to make a meal. In my second year, I was part of a team in which we built an autonomous underwater vehicle, and I spent many late nights designing and debugging the boards of the team. In my third year, as a part of a research project, I got to see how lithium-ion batteries that are used in our phones are fabricated. In my fourth year, I did an exchange semester at Denmark, where I got to see an offshore wind power plant as well as interact with many people working in the energy sector.
Over half of India lives and works in our villages, and their energy needs are quite different from ours. So one problem that we work on is improved design of biomass cook stoves. We work directly with communities in Maharashtra and use their feedback to improve the design of these cook stoves. Children in our villages can find it difficult to study in the evenings because of unreliable access to electricity. A team from IIT Bombay has implemented a large project for scalable distribution of solar-powered study lamps for rural school children. This is a unique project that targets local manufacture and distribution, thus strengthening the rural economy. We have very strong links with industry, including joint research projects, industry-sponsored laboratories, as well as industry-sponsored chair professorships.
The energy systems are in transition. We are moving from a large centralized fossil fuel driven energy system to a more renewable and sustainable energy system. This transition offers several challenges and opportunities. Our department plans to help manage this transition and provide leadership in education and research to develop sustainable energy systems for the future.
So you're probably wondering why you should choose the Department of Energy Science and Engineering and what advantages that this department will offer compared to other disciplines. So I'll list out a few important points which I hope will convince you to enroll for this program. So one is that there are two major factors that are currently driving this sector. One is the depletion of hydrocarbon-based energy resources like oil and gas, and the concurrent effect this has had on the climate change that we are noticing around us. So there's a global effort going on currently to find out ways to reverse the complications that have arisen from these hydrocarbon-based energy resources. This has driven the development of new energy technologies, cleaner and alternative and sustainable energy technologies such as solar PV and wind and hydrothermal and biofuels based. And the sooner we adopt these technologies, the better it will be for not just the economy of this country, but also for the health of life on this planet in general. So if you have a burning desire to make a contribution to this humanity as well as life on planet in general, then you should consider being trained for this energy sector. And this would enable you to make a contribution, and those who can make a contribution would always be in demand in the foreseeable future. Okay, so this is one. Second, so this discipline is very interdisciplinary. If you take any one such example, such as solar cells and batteries, you'll be trained in not just the physics and materials aspects, but also the electronics, the electrical circuitry, the thermodynamics, the heat transfer parts, and also energy policy and planning. So there are multiple skill set that you would be gaining if you enroll for this discipline. During the course of the study, if you like some particular aspect, I strongly encourage students to enroll for other courses in other disciplines, such as in electrical engineering or mechanical engineering, and even School of Management. You can get a minor in these disciplines as well. So in that sense, we are very flexible. You'll be gaining a wide skill set if you enroll for this discipline. And the third part is because this sector is in high demand and the government and companies are pouring money into the research and development of these alternative clean and energy technologies. So there are plenty of jobs in the market, and we have a very good record of getting of the students getting placed. And also, if you're interested in higher studies like masters and PhD, it's relatively easy at this moment to find positions in India and abroad. Okay, so these are three important factors. And I'll end by mentioning that you'll not just be joining the department, but also you'll be joining us in a mission to develop clean and alternative energy technologies. And I would encourage you to go through our website. It's www.esc.iitb.ac.in. You can also just Google search our department and Department of Energy Science at IITB, and the first link is our department's link. And so you can go through the department, you'll find a list of faculty, the course curriculum. If you have any doubts, feel free to write to me. My name is Karthik Sasihitlu, and I'm listed in the faculty in the department. My email ID is also listed there. So feel free to write to me, and I'll also put you in touch with the student representatives if you have any particular questions related to curriculum, etc. Okay, thank you.
Physics is one of the most important and fundamental sciences. It tries to answer a wide range of topics such as quantum computing, medicine, to gravitational waves.
This department started right at the inception of the institute, and it served the purpose of teaching as well as of very high quality research. In the old days, we started with spectroscopy, condensed matter physics, nuclear physics, elementary particle physics. But over the decades, we have gone on to include nanosciences, elementary particle physics with string theory, cosmology, also biophysics.
So in experimental condensed matter physics, we explore novel materials which manifest quantum phenomena on a macroscopic scale. So materials such as those which go into hard disks and computer memories, materials which will power tomorrow's solar cells, superconductors which flow electricity without any resistance, topological phases, and so on. We measure properties of materials down to low temperatures even lower than that of outer space. So with all this work, we will unravel fundamental physics behind these phenomena.
Nanoscience has emerged as an important area of research as nanomaterials reveal new physics which is different from their bulk counterpart. The Nano Experimental Group here at Department of Physics, IIT Bombay works on exploring the structure-function correlations in such materials.
When a large number of elements interact together, complex properties emerge. Our nature is full of such complexities at every scale. Here in the physics department, we study such emerging complexities. With the help of fundamental physics tools, we try to answer questions such as how DNA packs inside a nucleus, how cells divide, how tissues develop into complex organs, etc.
The area of photonics deals with the science of light and its manipulation. We investigate how interactions of light with matter can be used as tools to solve today's real-world technological problems. For example, spectroscopy is used to analyze materials of different kinds. Nano-optics deals with scaling down technology to very small dimensions, and ultra-fast optics focuses on studying events happening in the atomic and molecular timescales.
In theoretical condensed matter physics, what we do is to develop and use advanced theory and computational algorithm to understand the behavior and different properties of novel materials. In a nutshell, this basically involves utilizing the concept of quantum mechanics to understand different condensed matter problems at various time and length scales.
The Astronomy, Cosmology and Gravity Group works on black hole physics, early universe cosmology, multi-messenger astronomy, gravitational wave detection, dark energy and galaxies. The group primarily contributed to the detection of gravitational wave by LIGO-Virgo detectors, which received Nobel Prize in 2017. It also did the follow-up observation of the golden binary, which was the neutron star binary system, with the Indian Astrosat mission.
The Experimental High Energy Physics Group at IIT Bombay is involved in ALICE and CMX experiment at CERN, designed to study heavy ion collisions and proton-proton collisions at LHC energies. We here are primarily concerned with studying the properties of quark-gluon plasma and heavy ion collisions, which mimics the matter formed at early phases of universe.
Where does the spin of the proton come from? What gives neutrinos their tiny masses? What is the mysterious dark matter particle that appears to make up most of the universe? Does the top quark play any role in the Higgs mechanism? Are there any as yet undiscovered symmetries of nature that govern the rules that fundamental particles obey? Is string theory the correct description of nature at its most fundamental level? The Theoretical High Energy Physics Group of IIT Bombay is trying to answer these fundamental questions about our universe.
Answering these questions is expected to result in a better world for all of us.
Our alumni have gone on to occupy very important positions in academia and industry. They have become innovators, professors at major universities, and even administrators.
To an undergraduate like me, the 4 years I've spent in the Department of Physics has been nothing short of awesome. The unparalleled support for exploring, coupled with the well thought of and well maintained facilities, makes us gravitate to the department building. The computer room, the library and the seminar room become symbols of our existence. The department has been the shining light that has lit up the path ahead for all of us, making us who we are and who we become.
So welcome to the counseling session for BTechs in Engineering Physics. This presentation covers curriculum, research, industrial outlook and professional opportunities for folks pursuing the engineering physics program. So when one considers physics, physics is built on a bedrock of mathematical methods, and in this department we train you to understand mathematical methods alongside pillars of physics that you perhaps have pursued already in your high school. Classical physics, which is the motion of rocks and moving liquids, for instance, is something that we discuss in great detail. Quantum physics, perhaps, that you've been introduced to as the discussion of atoms. Statistical mechanics and thermodynamics, which is the interaction of many particles together, and electromagnetism, which is the theory of light. So together with all of these, we're able to build complex ideas, which you will study in courses, both core and elective. For instance, if you're interested in high energy physics, then there are two separate groups that pursue research in this area, and you can see how they draw from the various foundations here. Likewise, perhaps you're interested in the properties of matter, why do metals shine, so on and so forth. And that's a whole field of condensed matter, which is both pursued experimentally and theoretically in the department. Maybe you're interested in how light interacts with matter, and that's the photonics, the field of photonics, which is pursued very actively as well. Perhaps your interests are to take physics and take it elsewhere outside the department. For instance, quantum information pursues ideas of physics at the intersection with computer science and electrical engineering. And likewise, soft matter pursues the ideas of physics at the intersection of biology. Thank you.
So thank you, Sai. This is Sumiran Pujari. I'll tell you a little more details of what this engineering physics program is about. So the curriculum is broadly organized into three kinds of courses. One is basic theory courses, core courses, which allow you to learn this material, that the pillar courses that Sai talked about. Then there are laboratory components, which let you hands-on learn the various theoretical knowledge that you would get through the theory courses, for example, nuclear physics lab and so on. But there is also electronics lab, which, as you may imagine, is very important for any engineer to be good at. And then finally, you have a set of elective courses, which lets you explore many things within physics and outside physics as you prefer. So through these courses, the four big skills that you can expect to learn are the following. The first principle, thinking, which is essentially how to simplify and boil down your problem to the essentials, which, as you may imagine, is important in any field or endeavor that you might choose to take. Then there is precision hardware skill set, which essentially makes you think how to design hardware or software or anything at whatever level of precision is required, which is very important as you go in high-tech industry, for example. Then there is foundational thinking about constraints. What that means is how to work within the realistic constraints that reality or whatever problem area that you choose to focus on imposes on you, how to think foundationally within those constraints. And then there is interdisciplinary thinking, which allows you to communicate and formulate new ideas with people from outside your field. So after BTech, with all these skills and knowledge in your hand, what you can expect to do, so fundamental research, as you may easily imagine, and roughly 25% of our students, incoming students, go into fundamental research, but the rest, there's a whole wide world out there. For example, software and artificial intelligence is very current, as you know. Then there is finance and consulting and investment banking, that sort of thing, which you can choose to go into. Then there is high-tech industry, where you can directly go through placements like semiconductor industry, advanced materials, and so on, or you may choose to pursue studies to go into even higher specific industries in these directions, or other directions like education, communication, others like civil services, and so on. And all the skills and knowledge that you have gained through this would really help you in this regard. So all the best to you. Thank you.
Environment is everything that surrounds us. It has taken billions of years for nature to bring us in the evolution process to where we are today, as we know life to be. Water, soil, air, these are essential elements of what we know life and what gives life. Over the last few hundred years, human beings have skewed their relationship with these wonderful gifts. We now have environmental issues, especially in some parts of the world, which are very severe. And what we do for environmental science and engineering is to pick up some of these issues, bring in our fundamental understanding of physics, chemistry, maths, biology, and engineering to come up with solutions to control these problems.
Water is a finite resource. Only around 0.5% of Earth's water is available in the form of fresh groundwater and surface water in rivers and lakes. Today, many of our water resources have been severely depleted and their quality has deteriorated. The causes for this are rapidly growing population, urbanization, industrialization, and agricultural development. Research at CESE include developing various physico-chemical and biological processes to treat contaminated waters, exploring natural treatment systems such as constructed wetlands to treat municipal wastewater, and understanding the filtration mechanisms of contaminants in soil.
We are looking for different technologies like photocatalysis, advanced oxidation process to remove the emerging contaminants like pharmaceuticals, pesticides, and other industrial pollutants from water and wastewater.
One of the major environmental issues which our cities are facing today is how to manage its solid waste. As of today, 1,000 tons of this waste is dumped in the cities and nearby areas, which is causing air and water pollution. We look at this waste as a resource, and we are working on technologies to generate useful energy from this waste and recover valuable materials.
Another key aspect of our research at CESE is to understand what air we breathe in and how it affects us, and how can we achieve clean air. We have established active links with various agencies to monitor air quality at various locations through satellite data as well as ground-based monitoring stations. We have recently developed air cleaning device, Vayu, which has been commercialized and it has been deployed at multiple traffic intersections in Mumbai.
Global climate change has become one of the most discussed environmental issues in recent years. However, our understanding towards it is very limited. We at CSE work to know different precursors of the climate change. Along with it, we have developed various mathematical models to know the mathematical dynamics of the system. We have significantly contributed towards knowing the effect of climate change on Indian monsoon.
Land is required for growing food crops, for transportation and housing. However, it is limited, whereas the population keeps on increasing with the ever-increasing demand in food crops. Therefore, to tackle this problem, people started using toxic chemical fertilizers such as DDT to increase the agricultural yield. However, this also creates a severe problem for the ecosystem as well as the human health. We at CESE are working towards increasing this knowledge base on various fronts of water, land and air to create a more greener and healthier environment.
We have people from multifarious disciplines and backgrounds such as civil engineering, chemical engineering, biotechnology, environmental engineering, microbiology, chemistry, physics, mathematics, so on, working on various contemporary and challenging research problems associated with environmental pollution and its degradation.
And one hopes that over a period of time, we would be able to set up systems in which we do not cause these problems in the first place.
Hi, I am Professor Manoranjan Sahu, currently Associate Professor in Environmental Science and Engineering Department. So, Environmental Science and Engineering Department is one of its first academic units in India that initiated environmental science and engineering education. And it was established in 1977 as an interdisciplinary program and later established as a center in 1985, and then got the department status in March 2019. Our department offers several academic programs: BTech, MTech dual degree, MSc, PhD dual degree, MTech and PhD programs. So, we focused on various emerging environmental issues that our country faces currently on air quality management and pollution control, water wastewater reuse and management, solid waste and the hazardous waste management, and environmental systems modeling. We have 16 faculty members and all are from diverse engineering as well as science discipline, starting from chemistry, chemical engineering, civil engineering, energy science and mechanical engineering, and students from various disciplines join our department to solve emerging environmental issues, and the students are from agricultural engineering, chemical engineering, civil engineering, mechanical engineering, and also from various science disciplines such as chemistry, biotechnology, biochemistry, and physics. So one of the key strengths of our department it has high-class instrumentation and computational facilities, which is at par with any environmental engineering programs in worldwide, and faculty members are committed to excellence in teaching, research as well as public service, and which has significant linkage to various universities and institutions worldwide. And the students get the opportunity to work on the nationally relevant and global challenging problems of environmental issues such as air pollution, water pollution, waste management, and many other issues. And the course curriculum has been designed in such a way that the students get significant understanding of the fundamentals so that they can solve the real world problems. And also the students get the exposure for student exchange program to outside universities for 1 semester, and also students have the opportunity to take many electives in the department as well as in the institute, and also students do the R&D program when they are interested in a particular subject. So our alumni for last 35 years has been well established in various organizations, in academic institutions, research organizations as well as in industry. And many of our students have gone to abroad for higher education, and they are established in abroad as a faculty members as well as very important contribution they are making to industrial innovations. And many of our students have done startups in the past, and for helping the industries also handling the regional environmental issues. And the students have also emerging areas such as data science, AI, ML applications to environmental engineering. Let's look at the statistics of our department. World degree students. The students have been placed in various organizations starting from core environmental engineering to other organizations just like consulting, and to name some of these, they have been placed in Shell, ONGC, Tata Projects as a core environmental engineers. They have worked also, they have got the placement in as a consultant in various consulting agencies, and also they have worked as AI ML engineers also. They have got opportunities in various organizations. So these are some of the major recruiters of our students, and the placement statistics for last year is the placement is more than 95%, and the median salary has been around 15.5 lakhs per annum. And these are also the students get the enormous amount of opportunities, do the internship in their 3rd year and 4th year, and these are the list of the companies our students have done internship over last several years. And some students which are interested in research, they are also published research papers in the journals as well as in book chapter, and some of our students are also presented in international conference about the research findings. Thank you, and we are looking for you to join our department and join with us to help us to solve the real world environmental challenges. Thank you so much.
differential equations, harmonic analysis, Hilbert functions.
The Department of Mathematics was established in 1960 when IIT Bombay moved to its current location in Powai. With 47 permanent faculty members, it is one of the largest mathematics departments in the country and certainly the most diverse in terms of the areas of research that are pursued.
Because it's an ancient discipline which has been evolving for thousands of years, modern mathematics encompasses a dizzying array of sub-areas ranging from purely abstract to applied in the concrete. We have a large number of people working on different aspects of mathematical sciences in our department.
The study of partial differential equations is often motivated by questions in physics and engineering and finds applications in areas as diverse as plasma physics, aerospace science and weather prediction.
Research in the geometry and topology group encompasses algebraic geometry, topology, Lie groups and coding theory.
Problems in number theory are often easy to understand, but the solutions involve deep ideas from algebra analysis and geometry. Some of my colleagues work on new developments in classical fields like quadratic forms and Lie theory, while others work in the Langlands program, which spans representation theory of Lie groups, harmonic analysis and analytic number theory.
One essential aspect of my own research is the interplay between combinatorics on the one hand and algebraic geometry and commutative algebra on the other hand. Combinatorics is the study of discrete structures such as graphs, permutations and polyhedra. The problems that are studied in this area include questions related to counting or enumeration, understanding special extremal or almost extremal configurations, and studying the ability of computer programs to manipulate these objects.
Such activities of faculty members working in statistics and probability include theoretical probability, statistical inference, and stochastic differential equations. They also cover highly applied areas such as data mining and biostatistics, containing research projects that deal with improved multivariate Bayesian MCMC for machine learning, deciphering protein structural landscape, and characterization of cancerous mutations. They also cover disease modeling and design selection problems for non-normal and correlated data.
The faculty of the department, besides teaching and research, have also been involved in various outreach and mentorship activities across the country. Another noteworthy example is that of Professor I.K. Rana, who has organized the time workshops and has a joint collaboration with the government of Maharashtra to improve education in schools across the state.
The National Center of Mathematics based in IIT Bombay was established by an MOU between the institute and TIFR in 2011. Its main focus is in strengthening the graduate instructions by conducting workshops annually at introductory and advanced levels, with an additional focus on training teachers in colleges and universities.
Today, students can pursue no less than 5 different degrees in our department. Our most recent initiative is the starting of a 4-year bachelor's program in mathematics. This supplements the existing 3 master's degree programs, including one in applied statistics and informatics. In addition, over 60 students are pursuing PhDs in a very wide array of subjects. We are proud of our reputation as teachers. The very large number of Institute-wide Excellence in Teaching Award attests to our enthusiasm and commitment.
There are a couple of undergraduate programs in our department, one being the 5-year integrated masters and the other the 4-year BS program. Both these programs allow the students to explore the depths of their preferred area in mathematics and also help get a broad view of the subject.
The number of PhD scholars in the department is increasing steadily. At the moment, nearly 40% of research scholars are women.
The master's program of our department is carefully designed, keeping in mind the skill sets that a graduate should have at the end of the journey. The program is tough and rigorous, but at the end of it, the graduate is fully equipped for the next step, be it industry or research. It's a fantastic place to be in, and we couldn't have asked for more.
are some machines which use natural resources like fuels to produce power. There are some machines which use this power to produce other machines. There are machines which produce gadgets which we use in our everyday life. By creating, designing, manufacturing and operating various types of machines, mechanical engineers, like all engineers, provide us good, comfortable life.
Mechanical engineers are expected to design power generation units such as automobile engines and turbines. And they are expected to design mechanisms that transfer the motion and the power from the place where it is generated to the place where it is needed. For example, in automobiles, from the engine to the wheels. They are also expected to manufacture these. So they are expected to design forging presses, other manufacturing process like casting for metals as well as plastics, because all types of materials are being used in engineering nowadays.
Increasingly so, mechanical engineers are having to deal with systems which typically are not considered under the purview of mechanical engineering. For example, today's automobiles utilize a huge amount of electronic controls, and the algorithms that run these controls are driven by understanding of the behavior of mechanical systems.
With technology advancing and integration of various engineering fields, mechanical engineers work with robotics and making devices at the micro and nano scales. These are so-called MEMS or micro electromechanical devices.
Mechanical engineers are increasingly getting into biomedical engineering, especially medical device innovation. In our lab, we get doctors from various hospitals who come to us with unmet clinical requirements. We put groups of researchers from multiple disciplines like mechanical, materials, electrical, electronics, computer science, software, industrial design to solve the problem. In the last 2 years, we have developed almost 140 different medical devices, filed about 25 patents, and about 9 or 10 of these are already in hospitals or in industrial practice through startups or entrepreneurs.
Mechanical engineers are working with complex biological systems such as biomechanics, bone replacements, blood flow, and effect of radiation on human tissues.
We in the Department of Mechanical Engineering have a group working on advanced manufacturing. As a part of that, we have a center known as National Center for Aerospace Innovation and Research, working for developing aerospace technologies in the area of manufacturing. Currently, India is undergoing a phenomenal transformation. We feel that our technologies and our innovations will play a major role in developing the economy for the country.
The primary focus of our work is development of the next generation of propellants. We have chosen the cage hydrocarbon family from where we choose these compounds. They can serve as fuels, as oxidizers, as binders for solid propellants, any role. For fuels, we are trying to put them inside a gas liquid rocket chamber and burn them out so that we figure out what is the thrust, what is the specific impulse, and how good that propellant is.
Traditional topics of heat transfer and fluid flow are seeing investigation of complex flows in rarefied gases, visualization of flow using optical techniques, study of two-phase flow, and cooling in nuclear industry, as well as one of the most challenging heat evacuation problems of today, that is heat removal from computer chipsets. The quest to achieve lower and lower temperatures leads mechanical engineers to the field of cryogenics that is extremely important in space and fusion-based applications. Machining is getting more and more complex, and engineers are working in precision and micro-manufacturing areas, as well as machining of complex alloys. Complex parts are being made using powder metallurgy and 3D printing. Finally, in the modern world, engineers are driven to develop and test newer materials with complex properties. And here, mechanical engineers work at the bridge between mechanical engineering, material science, and physics.
We are still making machines, but they are getting more and more complex. We are still removing heat from devices, but these may be at the micro and nano scales. We are still reducing friction in fluids and in complex machine parts. And we are dealing with devices that were unthinkable even a decade ago. And all this to improve machine productivity as well as human productivity.
So in our department, we have broadly 3 divisions, which is thermal, design and manufacturing engineering. But a lot of research happens in a mix of all 3, interdisciplinary research. So for example, if you're watching this video on a computer or a mobile phone, all 3 disciplines are important to be able to design such devices. For example, if you see, this is a laptop cooling fan, and all 3 divisions of mechanical engineering and also other subjects have been used to be able to design and ensure that your laptop doesn't burn. So in our department, we have a lot of core courses, both theory and lab courses. And apart from that, we also have a lot of elective courses. And a lot of our research is aligned with those elective courses. For example, I work on something called magnetohydrodynamics. That subject involves amalgamation of fluid dynamics with principles of electromagnetism, which you may have studied during your JEE.
So mechanical engineering in general is considered as a very conventional, very traditional department. But as Professor Ranjan has already mentioned, the applications of the department are quite interdisciplinary. So let's take the design engineering stream within mechanical engineering, for instance. Typically, when somebody talks about mechanical design, you would think of beautifully 3D rendered models of cars or machines. But that's not all that is done. You know, there are actually faculty working on controls of robotic and mechatronic systems within the design engineering stream. And I work in the field of biomechanics. So I take very simple mechanical principles and apply them to the human body. And then we do a lot of interdisciplinary research along with surgeons and physiotherapists to make new medical devices or to change certain rehabilitation protocols. And this is also true for the 3rd stream of mechanical engineering, which is manufacturing engineering. You know, the faculty involved in the manufacturing stream actually work in very novel fields like laser manufacturing, micro-nano fabrication, as well as operations research.
So another highlight of our department curriculum is that there's a compulsory or core course on AI/ML. And in addition to that, a lot of other courses which have computational aspects. So you'll be getting a chance to learn a lot of coding in C++ and Python, and also some other softwares. And a lot of faculty are working with companies like DRDO, ISRO on projects of national importance. Apart from that, the student teams are also very active. There's a team called IITB Hyperloop team, then IITB car racing team, then satellite teams. They're also very active in the department. Apart from that, one faculty was even involved in consulting for this film called Rocketry, which some of you may have watched.
So to summarize, the faculty within the mechanical engineering department are administratively divided into these conventional design engineering, manufacturing engineering, and thermal and fluid engineering substreams. But the interdisciplinary research and education going on in the department transcends these departmental boundaries.
So mechanical engineering BTech in our department will prepare you for several core or semi-core opportunities. For example, industries like automotive industry, energy, aerospace industry, manufacturing industry. These are some of the industries where our graduates have landed up in.
If you are interested in pursuing higher studies, the breadth of topics covered in mechanical engineering gives you a very strong foundation to either go deeper into the subject that you like within the field of mechanical engineering, or to switch your departments. For example, I myself was a dual degree BTech plus MTech from mechanical engineering, and I switched my branch to bioengineering and pursued a master's and a PhD there.
So you're welcome to look at our department website for more details. And congrats to you once again. And we sincerely hope that you choose our department to pursue your BTech studies. Thank you.
So in this entire world, if you see, all these engineers have expressed themselves through the medium of materials. The car is made of steel, and the building is made of concrete, polymers, and so on. And then you have semiconductors, ceramic materials, and so on. So all these materials are the medium by which various engineers express themselves, express their creativity. So conversely, if you look at it, therefore, they are all constrained by the ability of the materials engineer to deliver higher performance in the materials that they use.
So we had our Bronze Age and we had our Iron Age, and what were those? People figured out how to use iron to make tools. People figured out how to make alloys. They made bronze. They used it to make tools. They used it to make mirrors and things like that. And they figured that these things could make their life better in some way or the other. But the problem is that that sort of an empirical knowledge, while useful, takes you only so far. But then, we want to make trains which go super fast. We want to fly aeroplanes. That's where engineering comes in. And that's where the science comes in.
You have a jet engine which is extremely efficient. Now, any mechanical engineer knows that higher is the temperature of the engine in which it operates, greater will be its efficiency. Then what stops them from using higher and higher temperature? It is a material in which that engine can be contained. So the progress in jet engine will take place at the materials engineer is able to deliver material steels or titanium alloys which will stand higher and higher temperature. We have worked for various agencies. PSLV rockets that is sent every now and then into space. The one of the steels that's the candidate material is developed at IIT Bombay to start. With defense, we have great tie-ups. Some of the materials that are used, for example, in submarines, we are working on them.
Invisible cloaking is like Harry Potter blanket, that if we are surrounded with that kind of material, that is a metamaterial, we can become invisible. We will not be able to be seen by the individuals. So that property would be called the invisible cloaking. We are working towards that goal at IIT Bombay to realize metamaterial and to realize invisible cloaking in the future.
We work on this entire gamut of materials: ceramics, polymers, semiconductors, and so on. So IIT Bombay has this complete rainbow of the exposure that a student needs in the area of materials as such.
Congratulations to you and your family members on clearing the JEE Advanced exam. I am Preeta Pant.
I am Guru Rajan from the Department of Metallurgical Engineering and Material Science at IIT Bombay.
So we were here to talk to you about our department. I understand that some of you may be familiar with metallurgy from your 11th and 12th courses. But what I wanted to tell you was that there's a lot more to metallurgical engineering and material science than just extracting metals from their ores. And it's very easy if you just look around you, sitting at home or sitting in a vehicle and driving to some place. There are materials everywhere, and our lives have been made comfortable because of advanced materials, right? Nowadays, we cannot live away from our cell phones. Right from the glass that is there on your cell phone, which luckily doesn't break very easily, to the chips that go inside, which make the cell phone work, to the same chips that make your washing machines, dishwashers, cars, etc. work. If some of you recall, during COVID, there was a delay in car manufacturing, and that was not because we didn't have enough steel, but that was because we couldn't get enough chips to be shipped in from other countries to make these cars. So materials are everywhere, and the education that we give you in the department is about how to tune the properties of materials or how to improve the properties of materials so that either we can make the current devices better or we can make ever newer devices which are either health saving or improve our quality of life.
So another way of thinking about the metallurgical engineering and material science department is to think of all the things that you have learnt in your school, how it is going to be used to understand materials. For example, if you have some material, its properties, we want to understand how the property comes about, then we have to make, let us say, a computer or computational material science where we use computers to study materials. We want a computer to understand what the material is. Then we have to mathematize it. We have to turn the problem into a mathematics problem, and then we have to explain it to a computer. Which means we have to understand the physics, chemistry, and sometimes biology of what is happening. We have to turn it into a mathematical description, which is then put into the computer using a programming language. So whatever you have learnt in your school in terms of maths, physics, chemistry, biology, computer science, everything is going to be part of learning about materials and metallurgy. However, we are going to do it in this kind of detail by taking specific materials, specific processes, specific manufacturing processes and the properties that come from these manufacturing and so on. So obviously our curriculum is wide and varied. There is lots of mathematics, numerical methods, for example, AML, for example. There's lots of programming, so you will learn computer programming, Python programming, and so on. And also other things like mechanical properties, electrical properties, how things get transported, and how things degrade, and so on. So there is a wide variety and depth to things that you will learn in the metallurgical engineering and material science department.
So we do understand, like my colleague said, that it's a diverse field and that you will have your own interest, and interest that will develop as you go through the curriculum. So we've kept the core curriculum from the department to be very small. So you do 10 core theory courses, you do 5 labs, and then there are lots of electives for you to explore your interest. And at the end, we are hoping that you come up with the ability to analyze things, you come up with good engineering skills, and the ability to put diverse things together to be able to solve complicated problems.
So obviously that means that you will be prepared for any job that you would get after the degree, and there are wide variety of jobs that are available. These are metallurgical industries, other materials industries. This could be, and you think of any engineering field. Of course, materials form the backbone, and hence as service providers we are needed in, it doesn't matter whether it is a chemical or mechanical or aerospace or civil. All these departments do have some component of materials built in. So a wide variety of companies hire our students, as you can see in the list, which is a non-exhaustive list of companies which are interested in hiring our students.
And then though there would be some of you, we hope, who would be interested in pursuing higher studies. Typically our students go to US, a smaller number goes to Europe to do their PhD, and universities like Berkeley, Northwestern, UCSB, Arizona State, Carnegie Mellon, Cambridge in the UK, they take our students, the good students go there. So it depends on you, depends on the choices you make at the end of your course here.
So welcome to the world of material science and engineering, and we hope you will start your journey from IIT Bombay. Thank you.
So that was the section where you learned about the various departments of the institute that you can enroll in.